on to the introduction of polynomial functions, which it was kind of newish right before we went on spring break, and then we came back, and we never really came back to the classroom. So this section was right before spring break, and some of you might not remember the most of it, so I would recommend looking back on it because it's a really great exam question. And same thing for 3.1 as 3.2, that this stuff is pretty much the same. The questions are all being asked in pretty similar ways. So without further ado, let's get started here. And it's asking you for a degree, which is going to come from up here. When there's nothing up there, you're going to assume it's 1. So this is a degree 4, because 2 plus 1 plus 1 is 4. And then once again, we're going to look at the sign so we can determine the end behavior. And the sign is always of that leading coefficient, which in this case is positive because there's no sign. So then I asked for end behavior. And if we know it's positive and it's degree 4, when it's an even degree, our ends go in the same direction. And when it's positive, they're both going to go up. So as x heads towards infinity, p of x is also going to head towards infinity because that's looking at this side of the graph. And x is headed towards infinity, y is also headed towards infinity. And then it asks for x towards negative infinity, p of x heads towards. When we're headed towards negative infinity, it's going like this. So p of x is once again headed towards infinity. Okay, so now let's look at our zeros for this graph. Our zeros are the same as our x-intercepts, which when it's written like this is pretty clear. When it's written like this, we kind of have to remember to set that equal to 0. So I'm going to draw a little chart. We have a 0 at 0, -2, and 1. And then you're going to say odd or even. And it's going to be odd based and even based on the power above. So this 0 goes to this one here, and it's a power of 2, so it's even. And these both have a power of 1, so they're both going to be odd. So when I plug this into my calculator to graph it, I'm going to get something like this. This is just a rough graph, but we know that both ends are up, and we know that we have zeros in these places. So that's how we know that that graph is correct. So if you have any questions on that, let me know. But most of those problems are similar and ask you to do the same process every time. So now I'm going to have you look at 3.3 with some polynomial division. I personally love polynomial division, and just a couple weeks ago in one of my classes, we did all this super hard work to get one of the solutions to a cubic equation, and then it came down to needing to find the other two, and I was absolutely stumped because I had two polynomials. But then I remembered polynomial division. So, and that solved the problem for me. So I think it's one of the first times it's really came like full circle for me. Some of these basic skills that you learn in algebra that you're just expected to have. So I thought that was pretty cool. You guys probably don't think that's cool, but it was pretty cool for me to see some of these basic skills, how they're used in further and higher math classes. So I have one synthetic and one long division problem for you, and then I have another one for you on the practice problem page. So we here have synthetic, and we're going to write this out like this. Remember, you need to put zeros for the missing place values. So I put a 0 here because we don't have a cube term. And the signs need to follow. Because this is already in my x minus c form, I can just put that 3 out there. I don't need to add any sign there. So, drop down my 1. 1 times 3 is 3. 0 plus 3 is 3. 3 times 3 is 9. Negative 14 times 9 is negative 5. Negative 5 times 3 is negative 15. 10 plus negative 15 is negative 5. And negative 5 times 3 again is negative 15. When I add negative 8 and negative 15 together, oh, I wrote this wrong. Well, we'll leave it as is. I get negative 23. So this is my remainder. And how do I rewrite this? I'm always going to drop 1 down. So I'm going to go negative 5. And then I have negative 5x. And then I have positive 3x squared. And then I have a positive x cubed, which is 1 degree lower than that initial term. So when you go to rewrite that, just remember, always 1 degree lower than original first term. Okay, so last one of this review chunk here. A nice long division question, which I love the long division. Synthetic is a little finicky for me, but I know a lot of you probably don't feel the same, and that's okay. So let's rewrite it in a form easy for us to do down here. Which this one's nice because no place values are skipped here, or degrees, I should say. Okay, so what times x squared gives me 3x cubed? Well, it's going to be 3x. 3x times 3x cubed, 3x squared gives me 3x cubed. 3x times 4 gives me 12x. Subtract these cancel out. I'm left with negative 5x squared. And I have 14x, and I'm subtracting 12x, so I have 2x minus 17. And now I need to figure out what I can do to get negative 5x squared with that x squared. Need to multiply it by negative 5 minus negative 5x squared. And negative 5 times 4 is negative 20. So then these cancel out. I'm left with 2x and negative 17 plus 20 because I have the two negative signs to give me a positive 3. And this degree is now lower than this degree, which tells me I'm done. It is okay to have a remainder that has an x in it. It can have an x squared in it. It's not always going to be a perfect situation for you. And I think that's important to know because a lot of us are looking for that perfect situation to unfold for us. So that's all I have. I will be back on Thursday. If you have questions, let me know. If not, one more time of listening to me talk to you guys. So, that being said, have a wonderful day. Let's hope this crappy weather goes away if you're in Ohio. And if not, I will see you on Thursday. Stay safe, stay healthy.